section, section 4 of chapter 6. We're talking about natural logarithms. So new words are being added to the dictionary, like, and both English and German evolved from the same ancestral language. The percent of common words from the ancestral language that are shared between two new languages can be used to estimate the number of years since the language is split. This relation is represented by a natural logarithmic function, which we're going to be learning about. So we can express this equation right here. N of r equals negative 5,000 ln of r, where r represents the percentage of common words that two languages might have, and n of r is the number of years since they split. So you could use this logarithmic equation to find out how long two different languages came from the ancestor language. And so we're going to use some equations of exponential functions with base e and natural logarithmics and inverse those, and then we're going to take the structures and express them and rewrite them using graphing calculators, models, and make predictions and use real world data. So let's go ahead and just do the first example because it's pretty easy. Well, maybe not, but we can practice though. All right, so we're talking about natural log or natural log, and it gets from the inverse of the exponential e raised to the x with the natural base e, and e we've talked about before, 2.7. It goes on forever, kind of like pi. And then when we have a natural log, it's just log with base e, kind of like the common log base 10, log base 10. Well, natural log is just log base e. So since it comes up so often, instead of writing log base e, we would just write ln, and that button is found on your calculator, ln. And then so ln of 6 is just meaning ln is log base e of 6. So e raised to what is 6. And basically that's kind of like the first example that we're going to do. And the same properties of logarithms can be applied to natural logs because they're both logs. Right, so here's an example. I'll do A, you can do B. So we're just going to rewrite this exponent in log form, right? So the base is e, so when I write the log, the base will be e, and then whatever's on the same side will no longer be on the same side, right? So it looks like that. And then instead of writing log base e, we just write ln. So ln of 14 equals x. So you can pause this video and go ahead and do B, and I'll do it right now so you can check your work. So pause it. So this is just e raised to x equals 7, and then ln is, I just wrote that wrong, e to the 7 is equal to x, and then rewriting this log base e, so that is just ln, and basically just these get switched places, so ln of x equals 7.